Maxwell's equations, and what are they? Gauss's law, Ampere's law, using electric flux, and distant current. Awesome! And it contains 4 different equations. One, Gauss's law. The second one would be Ampere's law. Why does it actually equal to 0? Let's check it out. Let's assume we have a closed surface. The magnetic field lines are continuous, so same number of field lines entering are actually leaving the surface. Therefore, our flux, in this case, it's going to be 0 in a closed surface, which mainly means that the magnetic field is actually 0 in a closed surface. Non-stop. Here we have the third equation. How did we find it? Let's check it out. Well, we know that the electromotive force actually equals to negative d flux over dt. And we know that the voltage actually equals to the electric field multiplied by ds. So now, if I combined these 2 equations together, this will give me the third equation of Maxwell's. Moving on to the fourth equation, which is most probably the longest and the most important equation. So let's derive it. We know that this is Ampere's law. So to this one we will add this one. So you're wondering, why did we add mu naught I distant to this equation? Let's check it out. Let's assume we have a wire, and this wire has a current I moving through it. And let's assume we have a loop beside it. We know that definitely there will be magnetic field moving through the wire, and this is the direction of the magnetic field. So since we have magnetic field, that means definitely we will have induced current. Therefore, the equation is going to turn out this way. Alright, now let's take mu naught and I distant and keep it aside. This will equal to dq over dt, which is the current, multiplied by mu naught. And then, to the right hand side, I will multiply it by mu naught dA divided by mu naught dA, which is actually equals to 1, right? On this side, let's remind ourselves of Gauss's law, which is electric field dA equals to dq over epsilon naught. And let us rearrange the equation above. I know that dq over epsilon naught dA is actually equal to the electric field. Therefore, I will replace it with E. Let's remind ourselves with the electric flux, that is electric field times dA. So now I'll replace the E dA with the flux. And do not forget to write E beside the flux to indicate that is electric flux. So this is the final fourth equation. So now we know that Maxwell's equations contain 4 main points to form 4 main equations, and actually the derivation of them is easy. Thank you so much for watching.